All right, good morning, kids. I want you to be answering these questions as we go. Press pause and then watch how I answer the questions. I don't want you to just copy my work, okay? So as we're going here, just go ahead and follow along and let's do this. We got to find some problems that are some fractions that are equivalent to 4/11ths. We're going to go 4/11ths equals 4/11ths equals 4/11ths equals. Okay? We're going to go times 2 times 2 gives me 8 over 22. We're going to go times 3 going to give me 12 over 33. I'm going to go times 4 gives me 16 over 44. These are all equivalent. Let's keep going here. Write two fractions equivalent to 2/6. And we just have two fractions. 2/6 equals 2/6 equals. We're going times 2 gives me 4 over 12. I'm going to actually divide this one because I can. 2 divided by 2 gives me 1. 6 divided by 2 gives me 3. Now, of course, you could have gone 3 times 2, 3 times 6, and gotten 6 over 18. I just wanted to show you that you can divide if you can reduce. Okay. Next problem, write three fractions equivalent to, you'll be able to see this one, 1/4. I'm going to make my screen a little bigger here. To 1/4, I've got 1/4 equals 1/4 equals 1/4 equals. Hopefully you guys like my hot pink pen today too. It's kind of fun. Okay. Anyways, multiply times 2 gives me 2/8. Let's go times 3 gives me 3/12. We're gonna go let's go times 5 this time. Times 5 gives me 5 over 20. Answers I will not accept on your test. 10 over 40, 100 over 400. I'm not going to accept these answers, okay? I want you to actually multiply by single-digit numbers to get some equivalent fractions. Which fractions are equivalent to 28 over 7? So just like our review we had yesterday, let's kind of take a look at how we're going to do this. 28 over 7, how many 7s? So we have 28 over 7. How many 7s go into 28? Exactly 4 go. So we know 4 is going to work. Okay. So let's take a look at 1 and 3/4. If I have 1 and 3/4, kids, 4 times 1 is 4 plus 3, it's 7 over 4. That is not 28 over 7. So we know that doesn't work. We know 3 doesn't work. Let's take a look at this last one here. 1 and 20 over 7. Do you see how this numerator is larger than the denominator? Remember that problem we did yesterday? Okay, they're going to try and trick you on these. So let's just kind of change this into a fraction. We have 1 and 20 over 7, right, kids? 7 times 1 is 7, plus 20 is 27 over 7. Is that 28 or 7? No. So we know this problem doesn't work. So 4 is the only answer that works. Next problem. Which fractions or mixed numbers are equivalent to 25 over 15? Well, let's reduce this one down. How many 15s go into 25? I've got 1. What's left over? 10 over 15. Okay, I don't see anything there, 1 and 10 over 15. So does that mean it's not right? Well, not necessarily. Let's look at this first one here. We have 1 and 4/6. Does that equal the same as 1 and 10 over 15? Well, we're going to have to reduce 10 15s down. And how we're going to do that, we have 10 over 15, right? Let's make this smaller. What goes into both? We're going to divide both of these, right, kids? Let's divide them both by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So let's rewrite our equivalent fraction, this fraction right here. Let's rewrite it as 1 and 2/3. So now we might be getting somewhere here. Take a look here. That one we know automatically works by doing this new method. So we have 1 and 2/3. So let's get rid of this old one here because we don't need it anymore because we already reduced it down. 1 and 4/6. So is this problem the same as this problem? Okay. Oh, I lost my hot pink. I'll get that back here quick. Got my hot pink back. Sorry. Let's take a look here. 2/3. Do they equal 4/6? Does that work? Times 2 equals 4/6, doesn't it? So we know 1 and 4/6 is the same as 1 and 2/3. Now I do know that 2/3 will not work. How about 1 3/5? Will that work? Can 3/5 equal the same as 2/3? It can't. 3 can't go into 2, so we know this doesn't work. So I actually have two answers that work. So this one was a little trickier because right away when we got to this step, we had to reduce it down more, didn't we, to get to this 2/3, and then we had to work with 2/3. I'll give you a hint when I hand out the test tomorrow, just to kind of see if you need that extra little hint there to do that on a problem like this. We'll keep going here. Which fractions or mixed numbers are equivalent to 2 and 2/7? Well, 2 and 2/7, so it looks nice here. They have all these as improper fractions, so we're just going to change 2 and 2/7 into an improper fraction. 7 times 2 is 14, plus 2 is 16 over 7. I only have one that works. Keep going here. Which fractions or mixed numbers are equivalent to 3 and 1/6? Once again, we have to change this into a improper fraction. 6 times 3 is 18, plus 1 is 19 over 6. There's my answer. Next problem. Which fractions or mixed numbers are equivalent to 10/3? 10 over 3? Let's take a look. How many 3's going to 10? 3. What's left over? 1/3. 3 and 1/3. This one works. How about 1 7/10? Will that work? We know that won't work because that's much smaller than 3. How about 7/3? 7 over 3. Let's see what that looks like. How many 3's going to 7? 2. And what's left over? 1/3. We know that's not right. Now we have one right here. This means 2 and 4 over 3. Okay, let's take a look at how to solve this problem. First of all, let's make this just an improper fraction. So we have 3 times 2 is 6, plus 4 is 10. 10 over 3. That's the number we started with, right? So we know this fraction works. Write a mixed number for the fraction diagram given below, and each the square is worth 1. So we have 1, 2, the big 2. Now this little triangle, we're going to kind of move it over so it'd be right here. Looks like we're putting it into fours. 1, 2, 3, 3 fourths. Next one. We got a 1 again. If we take our knowledge from that last problem, each little triangle is 1/4, right? Because this triangle right here would fill that spot, which would be half of a square. So this would be half. Oh, we have to make these as a fraction too. 4 times 2 is 8, plus 3 is 11 over 4. Next problem. 2 times 1 plus 1 is 3 over 2. Please don't forget to do both these for your test. Common denominators when we're adding up, we have them. So 4 is in my answer. 3 plus 1 is 4. This also equals 1. 4 and 8. This is supposed to be a 4. This is supposed to be an 8. We have to find common denominators. They're not the same, so we have to do what I've always been telling you. Stack our fractions up. Find a common denominator. 8. Times 2 gives me 2. Times 1 gives me 3. 2 plus 3 is 5. My denominator is 8. 5/8 is my answer. And keep on going here. Same again, we have to find common denominators. We have 3/4. We have 5/8. What number can 4 and 8 both go into? I know a lot of you are going to want to say 32, but take a look. 8 can go into 8, so let's make 8 my denominator. Go times 2 gives me 6/8. Times 1 gives me a 5. 6 plus 5 is 11. 8 is my denominator. Let's make this a mixed number. How many 8's go into 11? 1. What's left over? 3/8. Compare. Which one's larger? Do they have the same denominator? They do, so now we can just compare the numerators. 3 is bigger than 1. Same denominators. 7 is bigger than 4. Now we have the same denominators, but one's a mixed number. So we have to either change them both into mixed numbers or both into improper fractions. Let's just change them both into improper fractions. 3 times 1 is 3, plus 2 is 5 over 3. 4 over 3. What's larger? 5 is larger. So 1 2/3 is larger. Compare. We have a 5 and we have a 3. We have to stack these fractions up with a common denominator. As I'm moving around the room, today in class, I'm going to be looking to see if you are stacking your fractions. It's a must. You have to stack your fractions, okay? They both go into 15. Times 3 gives me 9. Times 5 gives me 10. So this right here means 2/3 is larger because this means 10 over 15. This one means 9 over 15. So this automatically means that 2/3 is larger. Find equivalent fraction for 1/5. Just like the review, we're dealing with hearts, right, kids? Help us remember. We have a 10, we have 100, and we have 1,000. 1/5, we're going to put into 10. Times 2 gives me 2/10. This is 0.2 as a decimal. When we're putting it into percent, we have to have 2 numbers after the decimal, which gives me an easy answer of 20%. We're going to be working here with a circle graph now, okay? First thing I want you to do is estimate. So I'm going to remove this. Let's take a look here. I know it's kind of tough to read. Take a look here at tennis. Tennis would be over 50%. If I were to kind of assume and estimate where tennis would be, I would maybe put tennis at, actually over 25%, I should say. I'd put tennis at about 35% would be my guess. Baseball, I'd put, looks like it's pretty close to 25%. Basketball looks like it is probably right around 10%. Hockey looks like it's almost 25%. We'll give it a 20%. And then pool, we'll give that one about 15%. If I add all these up, I lost my hot pink pen. If I add all these up, 35 plus 25 would give me 60. Okay, 60 plus 10 is 70. Plus 20 is 90. Plus 15 is 105. Now I'm going to use my percent circle to solve these. I'm going to start off with baseball. So this is where the baseball starts. Okay. I'm going to be reading that. You're going to be using your template on the test tomorrow. We're starting at 0. We have to make sure it's right in the middle as close as we can. Looks like baseball is right at 24%. That's pretty close to the 25% estimate. Now we're going to go ahead and measure basketball. I'm going to move this around, right? Always have the left be the 0. I'm going to move it. So that looks like it's right around 12% for basketball. I'm going to use green here to stay consistent. That's pretty close to the 10% estimate. I'm going to move down. Hockey is, looks like it's right about 20%. Hockey is right there. I have the 0. I'll put hockey at 20%. Keep on moving my percent circle around. Looks like this one's right around, get this exactly on there, 14% is pool. Then I'm going to find this last one, which would be tennis, which was my largest one. Right at the 0 there. Then I'm going to read it around, just like I've been practicing. Here's 30, here's 31. Now what you always have to do is add these up, right, kids? I'm going to add them up with blue. I have 31 plus 24, which gives me 55. I'm going to go ahead and add 12 to that. Gives me 7. Gives me 67. I'm going to go ahead and add 20 to that, which gives me 87. Then I'm going to add my 14 to that. See how close I get. I have 11. 101% is pretty accurate. I'll accept answers tomorrow from anywhere from 95% to 105% when you total all yours up. Almost done here, kids. Why is it helpful to make an estimate before finding a piece? Because if you can see here, see how these estimates kind of let me know if I'm on the right track. That's why it's important. To just see if your measuring and your estimates are similar. Because if this was supposed to be, if baseball was at 10% and all of a sudden I measure this one at 1%, I know I'd be really far off. Hey, let's take a look at these problems. We're going to make a circle graph for this data. I'm not going to make that, but you're going to be doing that with your scratch paper here. But I will be solving B, C, and D. If 100 students answered the survey, how many of them chose orange juice? Okay. Well, if 100 students answered, that is my denominator, right? So I'm trying to find out what my numerator would be. Well, if 25%, that'd be 25 over 100, right, kids? Remember all this practice we've been doing? Times 1 gives me 25 kids. So 25 kids would have picked orange juice. Let's do another example here. If 10 students answered the survey, so 10 is my denominator, how many of them chose apple juice? 20% chose apple juice, so I have 20 over 100. How does 100 get to 10? I'm going to divide by 10. 20 divided by 10 gives me 2. So that means 2 students picked apple juice out of 10. Last one, I have 50 students, so 50 is my denominator. Okay. How many of them chose fruit punch? 30% chose fruit punch. So I have a 30 out of 100. That's how we write our percents as a fraction. Divided by 2, 30 divided by 2 gives me 15. 15 chose fruit punch. Last problem, and you're not going to have to find out what 2/3 is, so you can automatically cross that off. We have to label. This is what I want you to do. I want you to label each one of these letters. What fraction would they be out of this square? That's what you're working on. Okay, kids? So this is how you're going to do it. So we have to find out what A is. This entire large square is worth 1. Okay? We're going to find out how many parts we have. So if we break this apart, that is half of the square, right? How many of these rectangles? This was a rectangle too, right, kids? Let's pretend. 1, 2, 3, 4. We have 4. Take a look here. There's 4, so this would be 1/4. Does that make sense here? So this is 1/4 of the half. Take a look. This is 1/4 of the half, so we're going to have to multiply that by 2, right? I'm kind of confusing here. So this is half, so let's take a look. How many of these do we have in this entire shape? Well, if this is half, so I have 1, 2, 3, 4. And if I were to split these up, kids, right? I have 1, 2, 3, 4, 5, 6, 7, 8. This would be 1/8 of my square. This would be 1/8. This would be 1/8. Right, kids? Now let's take a look at some more. I'm going to take out what we know so far. So if this is 1/8, this is 1/8, this is 1/8. Now, how many of these triangles do we have in the entire shape? I'm going to change this to different colors here. If I have this as one part, and remember we have 8 of these, right? Now, how many of these triangles? So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. See what I just did there? So that means I would have, each one of those triangles would represent 1/16. So I have 1/16 here, 1/16 here. This is 1/16. We have no more triangles. Now let's take a look at how much each one of these squares would be. It would be just like a triangle. So take a look. This right here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So each one of those little squares would also be 1/16. 1/16, 1/16. Now we have some big ones here. We're going to change this color to black. What do you think G would be? Okay, this would be 1/16. G is easy. So we have one triangle here, which is 1/16. And we have a square here, which is 1/16. So 1/16 plus 1/16 would equal 2/16. All right, kids? 1/16 plus 1/16 would equal 2/16. Okay. So we'll make that one 2/16. Last but not least, we have C here. Has 3, we have 1/16, 1/16, 1/16. If I add all those together, I would have 3/16. Now I can help you a little more with this tomorrow, but what I want you to do is I want you to take a look at basically each puzzle piece and see how many of those puzzle pieces are in the whole, and then find out what fraction of the whole is that puzzle piece. I know this got a little longer, but you're obviously going to be working on your review while watching this video. So you will have about an hour in class today to work on this. Hopefully this made sense. This will be an easy extra credit problem for tomorrow. All right, good luck.